All it takes to have a capable software organization is sound engineering and management practices. These methods are not new and they're not very complicated, but they are a dramatic change for software people and their managers. Not only must they learn new ways to work, but they must do so while they continue developing and supporting your organization's products and services. The Team Software Process, or TSP, shows engineering teams how to estimate and plan their work, and it guides them in tracking their work, reporting their progress, and managing product quality. The TSP also shows managers and executives what they can do to guide and lead their software teams. By introducing the TSP, organizations can achieve rapid benefits, and they can accelerate CMM process improvement. Before they can use the TSP, however, software people need to learn sound engineering practices. The Personal Software Process, or PSP, provides these skills. In PSP training, engineers learn to use defined processes, plan their work, track their time, and record their defects. They learn how to review programs and how to use defect data to improve product quality and cut test time. While these practices are not complex, they require considerable personal discipline. With proper support and guidance, however, engineers will use these methods in their daily work. And when they do, the results are truly extraordinary. The AIS Corporation is a small but highly respected software organization in Peoria, Illinois, and Chennai, India. They've been working on software process improvement for many years. They even won the IEEE Software Process Achievement Award in 1999. Before they started on process improvement, AIS scheduled performance was much like that of other software organizations, and they only made a profit in 1 year out of 5. Their first process improvement step was with SEI's Capability Maturity Model, or CMM. Reaching CMM Level 3 made a significant difference. Not only did their cost and schedule performance improve, they averaged a consistent 5.5% profit margin. In 1995, AIS introduced the Personal Software Process, or PSP. This is the basic engineering method behind the TSP. At this point, they started to consistently meet schedule commitments, and their profit margin almost doubled to 9.9%. During this entire period, AIS grew from around 20 employees to over 150. One reason for the improved performance of PSP-trained engineers is early attention to product quality. In the PSP preparatory course, engineers write 10 programs. With the first program here on the left, they typically find 110 defects per 1,000 lines of code, or KLOC. In other words, in compiling and testing, they find 1 defect in every 9 lines of code. This is average data for 298 experienced engineers. And from taking this course, these engineers reduced their compile and test defects by 5.5 times. This early attention to quality significantly reduces test time. Here, for example, AIS found that the average test time per 1,000 lines of code dropped from around 2.5 days to around 1/4 of a day. This is a 10 times reduction in test time. As you can see from a Boeing project, use of PSP methods can have a major impact. This chart shows data for 4 releases of a large system. Before starting on release 9, the engineers were trained in the PSP methods. Their test defects for the very next release were reduced by 75%. The impact of the PSP methods on test time was even more significant. This Boeing team cut test time by 94%. Instead of taking the 2 months normally required for a release of this size, testing took 4 days. The TSP provides the data needed to precisely manage a project. When engineers plan and track their work, they can see how their personal practices affect the overall project. Perhaps most important, they feel responsible for the plan, and they're committed to meeting it. Engineers do many things during a working day. In addition to designing products, they attend classes or meetings, help coworkers, or answer email. These myriad tasks can take a great deal of time, only some of which is spent on scheduled project work. In TSP, we call the time engineers spend on scheduled tasks their task time. Task time, it turns out, is a very powerful measure of team performance. At Allied Signal, for example, the engineers tracked their task time, and over several months, with concerted effort, they nearly doubled it. This meant they spent twice as many hours per week working on the job. When they start the TSP, teams find that they have typically spent less than 10 hours per week on project tasks. With the help of TSP data, they can increase their task time to 15 to 20 hours per week, or even more. After several years of work, the AIS engineers now generally average over 30 task hours per week. By tracking and managing their task time, most TSP-trained teams sharply increase their productivity. A principal problem for most development teams is unbalanced workload. This is where some engineers have much more work to do than others. For example, a lead designer will generally produce the initial design concept and review the design work done by the other engineers. He or she will participate in every design inspection, as well as reviewing and approving all design changes. Lead engineers have a great deal to do and are generally a bottleneck. The reason to do load balancing is to unload work from these overloaded engineers and distribute it among the other team members. With the TSP, teams take responsibility for balancing their workload, and they learn to do this dynamically as the situation changes. Here, for example, 9 engineers on an Allied Signal team each produced detailed plans for the next project phase. This next phase was planned to take 16 weeks, but the engineers had workloads that ranged from less than 1 week up to 49 weeks. Without workload balancing, the next phase would likely take much longer than the planned 16 weeks. It could even take as long as 49 weeks. When the team leader saw this imbalance, he started to reassign the work among the engineers. It was soon clear, however, that workload balancing was far too complex a job for the team leader to handle in this way. He then asked the team members to work together to rebalance their own workload. All the engineers participated, and in less than an hour, they had produced a balanced plan of 15 to 17 weeks. Now that they knew how to balance their plan, they could handle program changes. A few weeks later, the customer asked for a major requirements change. The teams then replanned and rebalanced its workload in just 1 day. When they can dynamically balance their workload, teams can minimize their project schedule. Now we turn to executive leadership. While the engineer's skills and team working methods are important, motivation is crucial. Motivation is a direct consequence of leadership style. Many managers mistakenly adopt an autocratic leadership style. They set arbitrary goals in the unfounded belief that engineers will not otherwise strive for an aggressive schedule. Autocratic management systems, however, are inefficient, arbitrary, and demotivating. They block ownership, limit initiative, and generally lead to discouraged and demotivated teams. With an autocratic system, the Soviet Union could not compete economically. Under autocratic management, the emphasis is on obedience and conformity. Such environments are constraining and ill-suited to creativity and innovation. While autocratic management may seem decisive and efficient, it is not appropriate for complex technical work. To get an intelligent and energetic participation of highly skilled professionals, you need to adopt what I call the rational leadership style.